In this tutorial, you'll learn how to simplify radicals. If you would like to see specific information on certain radical problems, you can jump right to that slide. Otherwise, work through the presentation and press play on each slide. Anytime you're trying to simplify a radical, the first thing you want to find are perfect square factors of the number inside. So while 20 has plenty of factors, 5 and 4, 10 and 2, 20 and 1, we're only interested in the factors that are perfect squares. And perfect squares are 4, 9, 16, 25, 36, etc. I'm not going to write the rest. But so we're looking to see if any of these numbers will divide the number inside the radical. And if more than one will work, you want to pick the biggest. So for 20, I can rewrite 20 as the product of 4 times 5. So I'm still taking the square root of the same amount. 4 times 5 would still equal 20. I've just broken it up into factors. The product property then says that because they're both inside the radical and being multiplied, I can split them and give them each their own radical. So now I have the square root of 4 and the square root of 5, and I actually know what the square root of 4 is. It's 2, so my final answer would be 2 square root of 5, or 2 radical 5. I don't need to write the middle dot because things back to back just imply multiplication, or you could write it, that would be fine as well. So for 48, I want to find the biggest perfect square that will multiply and get 48. So while 48 can be divided by 4, 48 can also be divided by 16, so I'm going to choose 16 because it's bigger. And 48 is the product of 16 times 3. The product property says that I can split them and give them each their own radical. And then I actually know the square root of 16 is 4. I don't know the square root of 3, so it has to stay inside. And that's my answer. Let's just say you had accidentally chosen 4 as that perfect square factor. Let's see what would have happened. So you would have made 48 into 4 times 12. You would have split them. And then you know the square root of 4, which is 2, and you have the square root of 12. The problem is, just like a fraction, you always have to check to make sure it's completely simplified. 12 can actually be broken up again, so I just dropped down that 2, and I can split 12 into 4 and 3. So then this 2 right here that's out front just drops down. The square root of 4 is 2, and these two, because they're kind of back to back, are just multiplying. And then I have the square root of 3. And then if I actually multiply the two numbers that are outside of the radical, I'm going to get 4 radical 3 for my final answer. So you can see that you get the same final answer depending on which path you take. But this one over here, the green one's definitely a better option because it gets there a lot faster. So that's why you want to pick the biggest perfect square factor. So in this problem we're dealing with multiplying radicals, so I have 5 radical 3 times 2 radical 6. Now it's also important to note that while that's multiplication, there's also multiplication occurring here, and there's also multiplication occurring here. So since the only operation throughout the entire problem is multiplying, and multiplying is commutative, that means it really doesn't matter what order I multiply them. It has to do with the location of the items in terms of are they inside or outside the radical. So since 5 and 2 are both outside the radical, I can actually multiply them to get 10. And then the product property works the other way, which says that if two numbers are inside, like 3 and 6, I can multiply them together as well. So I'd bring down my 10, and now I have the square root of 18. But then I have to check, just like you always do, to make sure that number doesn't have any perfect square factors. And it does. 18 can be made into 9 times 2. But then I could split that and make it into 10 times the square root of 9 times the square root of 2. But then I know the square root of 9 is 3, so I'd have 10 times 3 square root of 2, which would be 30 radical 2. That's my final answer. In this problem, we're going to review how to use the quotient property. Not only do the numbers inside the radical have to be completely simplified, the other problem is that you can't have a fraction in a radical. So right now we have this fraction of 40 over 121, and that's inside a radical, which can't happen. The quotient property says that if you have two numbers inside a radical that are being divided, which we do, just like the product property, you can split and give them each their own radical. It remains a fraction. Nothing moves where it is. So 121, which was in the denominator, is still in the denominator. It just has its own square root. 40 was the numerator. It's still in the numerator. It just has its own square root. So now I can actually simplify that. So I'd have square root of 40, and then the square root of 121 is 11. Most people would think that you're done, but you have to check the number inside the radical and make sure that it has no perfect square factors. which it does. So 40 can be split into radical 4 and radical 10. And then I know the square root of 4, which is 2. And the square root of 10 I do not know. So I'm going to leave that as the square root of 10. And my denominator is 11. So my final answer would be 2 radical 10 over 11. It's also important to note that if 2 and 11 were both even, you could reduce them because they're both outside the radical. And regardless, since 10 is inside the radical, it can't be reduced with anything because there's nothing else located inside a radical. So in this problem, because I have a fraction of 11/5 inside the radical, the first thing that I have to do is split it. So I'm going to make it radical 11 over radical 5. And this time, neither of these two radicals can be simplified, but because I have a radical in the denominator, I can't keep it that way. That's not considered to be in simplest form. So to cancel out a radical 5 in the denominator, I would multiply it by itself, which is radical 5. And the golden rule of fractions is whatever you do to the bottom, you also have to do to the top. So radical 5 times radical 5, if I apply the product property, would be radical 25. And on the top, I'd have radical 55. And I'm allowed to multiply 11 and 5 together because they're both inside the radical. Now I have two square roots, but I actually know the square root of 25, which is 5, and then I have the square root of 55. Now, while 55 has factors, such as 5 and 11, none of them are perfect squares. It can't be divided by 4, 9, 16, 25, 36, 49, etc. And even though 55 and 5 are both divisible by 5, 55 is inside the radical, 5 is outside, so I actually can't simplify them. So I'm going to leave it as the square root of 55 over 5. So to start this problem, I'm going to split them each, radical 6, radical 40. And then I'm actually going to simplify the 40 before I move on. I'm going to make it into the square root of 4 and the square root of 10, which would become square root of 6 over 2 radical 10. So now the problem radical is this radical 10 right here. So that's what I'm going to get rid of. I'm going to multiply top and bottom by radical 10 to get rid of it, which on the bottom would give me 2 radical 100, and on the top would give me radical 60. So on the top, both 6 and 10 are located inside the radical, so I can multiply them to get 60. And it stays in the radical because I haven't taken a square root yet. And on the bottom, 10 and 10 are both in the radical, so I can multiply them to get 100. And the 2 is outside, so that just kind of comes along. So now I have square root of 60 over, since radical 100 is 10, and this 10 would be multiplying this 2, it's over 20. And now I can simplify 60 into 4 and 15 over 20. The square root of 4 is 2 radical 15 over 20. And now, because 2 and 20 are both outside the radical, I can actually reduce them and get a 1 and a 10. So my final answer is going to be radical 15 over 10. So that's really just one way I actually could have solved that problem. Probably the way that most people would do it. Another way is because 6 and 40 start both within the radical, you could actually reduce it to, if you divide both by 2, you would get 3 over 20. And then you could split that to radical 3 over radical 20. And then I would reduce or simplify 20 to radical 4 radical 5. So now you have radical 3 over 2, because that's the square root of 4, radical 5. Then I would multiply top and bottom by square root of 5. So on the top you'd have radical 15, and on the bottom, square root of 5 times square root of 5 is square root of 25, which is just 5. 5 times 2 is 10. So this way, it's just another way to get to the same answer. You can see the answers match, but not as many steps in this situation, but if you just forget to reduce first, you can do that. At this point, some people might have also multiplied top and bottom by radical 40, which is fine. You're just going to have a lot bigger numbers and a little bit more simplifying to do in the end. Moving on to adding and subtracting radicals. So just like when you combine regular like terms like 2x and 3x, the variable pieces have to match exactly in order to be able to combine them, and then all you do is add or subtract their coefficients. So 2 plus 3 would be 5, and you keep the x. The x doesn't change. Same thing here. So to add or subtract radicals, the number inside the radical has to match exactly, which it does. So we're just going to add the coefficients. So 2 plus 4 would give us 6. And just like down here where the x's had to match exactly and we kept it just as x, We're going to do the same thing up here with radical 3. We're going to keep it radical 3. It doesn't change. It's exactly like down here. X and x, when you add them, you still have x. You just have 5 of them. We still have radical 3's. We just have 6 of them. So 6 radical 3 is our final answer. On the next example, since the numbers inside the radicals don't match exactly, we cannot subtract, but 20 is not in simplest form. So we're actually going to simplify 20. So 20 we're going to break up into 4 and 5, and I'm just going to drop down that 2 radical 5. So then square root of 4 is 2. 2 times 9 would be 18. So 18 radical 5 minus 2 radical 5. So by simplifying 20, we actually now have like terms, radical 5, radical 5. So I just subtract the coefficients. 18 minus 2 is 16. 16 radical 5. Distributing radicals is really just like multiplying and applying distributive property at the same time. So first I'm going to distribute 2 radical 5 to 6 radical 8. And again, 6 and 2 are outside the radical, so I can actually multiply them to get 12. 8 and 5 are inside the radical, so I can multiply them to get 40. Bring down my plus sign. Distribute again. 2 and 2 are both outside, so I get 4, and then radical 10. So now I would check to see if I can combine, which I can't. They don't match, but 40 is not in simplest form. So I'm going to split 40 into 4 and 10. Drop down my 4 radical 10. And then the square root of 4 is 2. 2 times 12 would be 24. So 24 radical 10 plus 4 radical 10 would give me 28 radical 10. And the last type of problem involving radicals is FOIL, which if you remember means first, outer, inner, last. So 2 radical 2 comes first, and 4 radical 6 comes first in their parentheses. So we're going to multiply those together. So 2 and 4 are outside, so I get 8, and then 6 and 2 are inside, radical 12, plus outer, so 2 radical 2 and 5 radical 8 are on the outer edges. So I multiply, so I would get plus 10 radical 16, plus, then I do inner, which is 3 radical 5 and 4 radical 6. So I get 12 radical 30, and then last, which is 3 radical 5 and 5 radical 8, so 15 radical 40. So now I'm going to go through and check to make sure all the numbers inside are simplified. So 12 I can break up into 4 and 3. 16, the square root of 16 is just 4, and 4 times 10 would be 40. Plus 12 radical 30. 30 can't be simplified even though it has a lot of factors. None of them are perfect squares. And then 40 can be broken up into 4 and 10. So here the square root of 4 is 2. 2 times 8 is 16. So 16 radical 3 plus 40 plus 12 radical 30 plus square root of 4 is 2. 2 times 15 is 30. 30 radical 10. Just so happens that none of my radicals are like terms, so that would be my final answer.